In this video, we will demonstrate how to work with Java to automate the Docker container management tasks. We will begin by launching our Oracle VM VirtualBox. We can launch it by simply double-clicking on the icon. The Oracle VM VirtualBox has Docker installed on it. We will right-click on Default Saved and start the virtual machine. It restores the virtual machine from the location where it was saved and provides access to the root default. Now we need to identify the IP address which has been allocated to this particular virtual machine by our system. We will run the command ifconfig to bring up all the networks that are configured. From this list, we will be focusing on Ethernet 1, and the IP address specified here is 192.168.99.100. Let's make a note of this particular IP address. Now we will focus on the next task, which is to start communicating with our Docker using a Java program. For that, we will be using an Eclipse IDE to write our application. Before we begin writing applications, we need to check and ensure that the Docker plugin is already installed. We will access the Help tab from the top navigation pane and access Eclipse Marketplace. Access the Install tab, and we will find this Eclipse Docker Tooling plugin is already installed and available for use in Eclipse. Now, if this plugin wasn't already installed, we would need to install this plugin by following the conventional approach of installing plugins in Eclipse. Since the plugin is already installed, we will get a perspective, and that perspective is the Docker Tooling. When we access the perspective, we will find a Docker Explorer tab, and this tab provides information about the Docker engine to which this Eclipse IDE is currently connected. The IP address indicated here is 192.168.99.100, followed by the port 2376. This is the same IP address which we tracked in the Oracle VM VirtualBox. Now let's navigate back to the Java EE perspective and plan how to go about writing our first application that we can use to maintain or manage Docker containers. Now we will create a new Maven project. We will select Quick Start, specifying the group ID as Sample1 and Artifact ID as Sample1 as well. Then click Finish. So now our Maven project has been created, and it includes certain Maven dependencies as well. By default, a Quick Start project includes a JUnit Maven dependency. Now we will access the pom.xml and add Docker as a dependency. In the dependency section of pom.xml, we will have new dependencies, and these dependencies will include specifications to provision Docker in our application. We will begin by adding the group ID. We will add Artifact ID, and we will add version as well. So these are three important entries that are required in our Maven project to pull in all the libraries of Docker. Now, we will specify com.github.docker java as a group ID. Then we will specify the artifact ID as Docker Java. Finally, we will specify the most recent version, which is 3.0.14. After having made these specifications, we have to ensure that we are saving them. Now we will find all the remaining dependencies apart from JUnit have been added as well. These dependencies can help us write the client application for Docker. We also have to ensure that we are using the right version of Java as a JRE system library. We can change this by accessing the Java build path libraries. We can edit the JRE system library and ensure that we are selecting the right Java SE version. Let's apply the change that we just made and click OK. Now we can close this pom.xml file so we can begin configuring our application so it can communicate and perform the necessary tasks on the Docker container. Under the src main Java folder, there is a package called sample1.sample1. Here we right-click on this package and create a new class. Then we will specify the name of this Docker as Docker Client App. We will check the box, public static void main box, and click Finish. This is the stub where we can specify the configuration to connect to Docker. We will begin by adding default Docker client config. Then we will add config is equal to and specify a statement that can create an instance of the default Docker client config. It uses factory pattern in order to help us get the Docker config builder. We will specify another important property, which is with Docker host, and we will replace this Docker host with the IP address of the virtual machine where our Docker is running. In case we don't remember the IP address, we can bring up the Docker Tooling tab and capture the IP address which is specified in this tab. We will specify TCP followed by the IP address, which is 192.168.99.100. And we need to specify the port at which the Docker engine is running, which is 2376. Finally, we will add the function build. Now this builder will take the responsibility of building a default Docker client config, which we will use to communicate with Docker to perform various management tasks. Now we will build a Docker client, and there's a class called Docker client in the library which we have added. We will take a client as the variable, which will hold a client instance, and we will use Docker Client Builder to build the Docker client. Then we will add a get function to get the instance and pass the Docker client config, which we have created. We will select config from these options. Finally, we will call the build method to build our Docker client. So now our Docker client is ready. Let's explore the version of the command which we will be using. For that, we simply use sysout, specify client to get the version information, and use a method called version_cmd. Let's save these configurations so we can run it. Now in order to run this configuration, we will click on the radio button that says Run Docker Client App. We will observe that it logs certain information and provides the right API version which we are using. After we have confirmed the API version, we will explore the containers that are created in this particular Docker installation. For this, we can use the client API or client object, which we have already created. So now we will declare a list. For example, we will take a list from Java util, and we will be very specific that we are using the container because we want containers to be populated in this. Then we will add a variable as containers, which is equal to client, because the client contains the method to perform various tasks. For example, we can build image, attach a container, connect to the network, copy archive to a container, create volume, and create network. So we can construct various objects of Docker by using this particular client. As of now, we will explore how we will get the list of containers, so we will use a method called listContainersCMD. Now we also want to pull the list of all the containers, irrespective of their states, so we will add another method, with showAll, and pass a Boolean value which is true. This will ensure that it executes this particular parameter and shows all the containers irrespective of their states. Finally, we will call the execute method. This method will populate this particular list with all the sets of containers that exist in our current Docker instance. Then we will add iterator in order to iterate this particular list and ensure type safety using container. We will declare this iterator as it equal to containers, which is the list followed by iterator. What we have done is we are getting the iterator which is associated with this particular container, and this iterator will have the capability of iterating in the list of containers and provide us with the capability of working with each container. Then we will include while and specify it.hasNext, since we want to iterate till there are values. We would like to see the number of containers. We will add sysout, which is system.out.println, to print the value that we want. Now we want to print container size, and this size is the total number of containers. So we will add string to ensure that we get the right message. This will display the total number of containers. Now we want to iterate in each container, so we add container, and container is equal to it.next. This will initialize with the elements that are included in this particular list called container. Now we will add a configuration to determine certain properties of those containers. We will take sys out, and the first thing that we will specify is image, the image on which this container is built. We will specify container.getImage. And if we want to pull the image ID, we can specify that as well. Then we will add a certain separator in order to separate the different values. For example, we are using the separator as equal to in this case. To get the status of that particular container, we will specify container.getStatus. Similarly, we can probe for various other properties of this particular container. We will save these configurations and run this application again. We will click on the radio button to run this application. Let's bring up the console. We will find the total number of containers, which is indicated as 9. It also indicates the containers and its respective state. So there are 4 Ubuntu containers in different states. There's 1 SHA container, 1 RabbitMQ container, and 1 Postgres container, and 2 Debian containers. Depending on the number of existing containers, it will display that particular list of containers. So by using this Java API, specifically which contains classes like default Docker client config and Docker client, we can communicate and work on containers. For example, if we want to create a container, we will simply add a method called client.createContainerCMD and pass the parameters that we want to create. In this case, we will pass the name of the containers, which is Redis. We will save this added configuration and run it again. When we bring up the console, we are unable to find the state of the new container because we created just a few seconds ago. So using Java, we can perform various tasks that are related to Docker container management. This particular program was executed without any errors, which proves that there are matured APIs for Java, though unofficially available to help us interact and automate Docker tasks using Java. From this video, we have learned how we can automate various Docker container management tasks like creating, starting, and stopping containers using Java.